Welcome to our second lecture. In first lecture we have seen the fundamentals of the mechanics, laws of physics and different types of force system. Today we will see the very important part of engineering mechanics, that is composition of forces and resolution of forces. First of all, what is meant by composition? Composition is the process to determine the effect of number of forces acting on the object by a single force. In other words, it is a process in which we are determining an equivalent force which produces same effect as that of number of forces acting on the object. Why composition is required? Because whenever an object is under the action of forces, assume that F1, F2, F3, these three forces are acting on block A. Then we have to find what is the effect of all these forces on block A. To determine the effect, whenever vector quantities are acting simultaneously, it is very difficult to directly add and subtract the quantities. We will see a very best example. If a block is there, two forces acting of magnitude 5 Newton and 10 Newton, then you will say that the resultant is 5 Newton, acting towards leftward. Same problem if you will change the values like this. I will change the arrow. Then you will say the resultant is 15 Newton towards leftward. Means we are adding and subtracting the forces. Assume that if it is in opposite direction of 10, value is 10, then you will say that the resultant of this force system is 0, because both are cancelling each other. It is very easy to add and subtract when two forces are along the same line, collinear forces like this. But if another force of 20 Newton is acting, now it is very difficult to determine the resultant of these three forces. That's why whenever the vector quantities are not along a same line, then we have to use some other methods to determine the resultant of the forces, because the resultant is very important. The final effect of all the forces acting on the object is depend on the direction of resultant of that force system. So the determination of the resultant is called as a composition of the forces. There are different methods to determine the resultant of the force system. There is one method that is called as parallelogram principle. Parallelogram principle states that if two forces acting concurrently on the object being represented in magnitude and direction by two adjacent sides of the parallelogram, then the resultant is diagonal of the parallelogram. It is a statement of the law of parallelogram of the forces. We will understand this principle with the help of the figure. Assume that F1 is the force represented by vector AB and F2 is the force represented by AB. Both are acting at point A. Law of parallelogram states that if two forces are acting concurrently being represented in magnitude and direction by two adjacent sides of the parallelogram, then the resultant of these two forces is diagonal of the parallelogram. Means the force F1 and F2 acting at A, the resultant is R, which is represented in magnitude and direction by the diagonal AC. Now how to find the resultant? To find the resultant, I will split figure we will give the name ABCDE. As it is parallelogram means opposite sides are parallel to each other. If angle theta f1 and f2 has the angle theta, then this angle is also theta. I will apply the Pythagoras theorem in triangle ACE. AC square equal to AE square plus CE square. Now AC square means R square. AE square, it is the addition of AB and BE. Therefore I will write AB plus BE square plus CE square. But we know that the AB is represented by F1, but B, the value of the B we don't know, and similarly value of C also is we don't know. So listen here, in triangle ACE, cos theta equal to adjacent upon hypotenuse AE in triangle BCE, cos theta equal to BE divided by BC. BE divided by BC. BC, the value of BC is F2. It is if AD is F2, therefore BC is also F2, because parallelogram means opposite sides are equal and parallel to each other. Therefore BE equal to, we have to find the value of B, and BC is F2. Therefore BE equal to F2 cos of theta. Similarly, in same triangle of BCE, if you will take the sin theta is opposite upon hypotenuse CE upon BC. CE we have to find, therefore we will write as it is CE, and BC is F2. Therefore CE equal to F2 sin theta. I will write here F2 cos theta, F2 sin theta. We will put the value of BE and CE in this equation number 1. Listen here, R square equal to AB means F1, BE means F2 cos of theta bracket square, CE means F2 square sin square theta. We will expand the bracket. R square equal to F1 square plus twice F1 F2 cos of theta plus F2 square cos square theta plus F2 square sin square theta. We will put F2 common. So this, the equation will become R square equal to F1 square twice F1 F2 cos of theta plus F2 square. If I have to find only resultant, then R equal to, I will take the under root on both the sides. R equal to F1 square plus twice F1 F2 cos of theta plus F2 square. It is the mathematical expression to determine the magnitude of the resultant acting on parallelogram. Means if two forces are acting as two adjacent sides of the parallelogram, then the resultant can be found as R equal to under root of F1 square plus twice 1 F1 F2 cos of theta plus F2 square. It is a magnitude. If I want to find the resultant of the arc, assume that this resultant is represented by alpha. Alpha is the resultant. So we will see in triangle. In triangle AEC, tan alpha equal to opposite upon adjacent. Opposite means CE, adjacent AE. C is already, we know that C is F2 sin theta. Therefore AE is addition of AB and BE, F1 plus F2 cos of theta. Therefore alpha equal to tan inverse F2 sin theta divided by F1 plus F2 cos of theta. It is the direction of the resultant. When you have to find the resultant of the two forces being represented in magnitude and direction by two adjacent sides of the parallelogram, then the magnitude is given by r equal to under root of f1 square twice f1 f2 cos theta plus f2 square, and direction alpha is given by tan inverse f2 sin theta divided by f1 plus f2 cos of theta. But very important point, the key point for using the law of parallelogram of the forces is, this law is useful only when two forces are acting concurrently. Concurrently means the point of application of the forces is same. Whenever two forces are there and concurrent forces, condition of concurrency is applicable, then only we can use law of parallelogram of the forces. There is one another method, because there are number of methods to determine the composition of the forces. But very important thing is that instead of number of process methods, theorems, we will use a general method to determine the resultant of the force system. So to have a look on general method to determine the resultant of the force system, means this method is applicable to n number of forces, whether the forces are 2, 3, 4, no issue, we can use very easily to determine the resultant of the force system. In books there are different methods also given for number of forces, like sine rule, cosine rule also we can use to determine the resultant. But instead of remembering all these laws, we will go for simple one, that is general method. To have the understanding of general method of the forces, very important thing is that resolution of the force. Resolution of forces. Why resolution of forces are required? First of all, what is mean by resolution? Resolution means we are splitting a single force into its component without changing its effect on the force system. It is the reverse of the composition of the force. In composition of the force, we are finding the single force which produces same effect as that of number of forces. But in resolution, we will split a single force into its composition and components of the force without changing the effect of the force system. Very easy. Assume that force F1 is acting on point A, having angle theta. To split it into its component, I will make a triangle A, B and C. Now listen here, in triangle ABC, cos theta equal to AC divided by AB. and AB is force F. Therefore, AC equal to AB cos of theta. Therefore, AC equal to F cos of theta. AC equal to F cos of theta. Similarly, if you apply the sin theta equal to opposite BC upon AB. Therefore, BC equal to AB sin theta and AB is F. Therefore, BC equal to F sin theta. AC is F cos theta and BC is F sin theta. These are the two components acting rightward and upward components, making an angle of 90 degree. We know that to determine, assume that F cos theta and F sin theta are two components, two forces which are acting perpendicular to each other. Means perpendicular to each other means if we will use law of parallelogram of forces, R equal to under root of F1 square plus twice F1 F2 cos of theta plus F2 square. Now if we put here theta, the angle between the force F1 and F2 means force first and second. Here F cos theta, F sin theta angle is 90 degree perpendicular to each other. If you will put this 90 degree instead of theta, then cos 90 is 0. Cos 90 0. Therefore, R equal to F1 square plus F2 square. That is the result. If you will put F1 square and F2 square values, F1 is F cos of theta square and F2 is F sin of theta square. Therefore, the R equation of R will become F square common in both cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. Therefore, R equal to under root of F square, that is equal to F. This is very important point. Means resultant is F. What it means? The forces F cos theta and F sin theta combinedly producing the same effect as that of force F. Means F cos theta is horizontal component of the force F, which is inclined at an angle of theta, and F sin theta is vertical component of force F, which is inclined at an angle of theta. In simple language, we will see if any force is inclined at some angle. Assume that this force F is inclined at an angle of theta, then it can be split into its two components. One will be horizontal and another will be vertical. The magnitude of horizontal force will be F cos of theta and magnitude of vertical component will be F sin theta. Horizontal force cos of angle, vertical force sine of angle. It is the part of the magnitude, and direction of these two components is depends on the quadrant in which force is acting. The very important point, because the force is a vector quantity, and for vector quantity we require magnitude as well as direction. So why it is rightward, why not leftward? It is rightward because the force F is in first quadrant. We know that the quadrant of the forces, it is first, second first quadrant, if force is lying in first quadrant, the component will be rightward and upward. If it is in second quadrant, if the force is acting like this, force F, then the component, horizontal component will be leftward, magnitude will be same, F cos theta, F sin theta, but the direction in this case it is leftward, and for vertical it is upward, because this force F is acting in second quadrant. If force is acting in fourth quadrant, force F, angle theta, then horizontal component will be acting in rightward direction and vertical component will be in downward direction. The magnitude will remain same, F cos theta, F sin theta, but direction is different as that of other forces. The force acting in third quadrant, assume that it is acting in third quadrant, force F, then the horizontal component magnitude will be same, F cos theta, but it will act towards left, and vertical component will act towards down with same magnitude, F sin theta. In magnitude there is no problem. Horizontal is with cosine and vertical will be with sine. And very important point is that this angle theta is measured from horizontal reference line or from x-axis. Always remember, if this angle is given from y-axis, assume that it is 30, then we for simplicity you can reverse the, when angle is given from y-axis vertical plane, this will become F sin theta, this will become F cos theta, but it creates a confusion. That's why we will use only a horizontal reference, means if it is from vertical it is 30, then in horizontal it is 60. Okay, it is very clear now how to resolve the forces. The resolution will be done with the help of the inclination with horizontal reference line or x-axis. The horizontal component will be force cos of angle. Vertical component will be force sine of angle. Now, what is the general method to determine the resultant of the force system? Very easy. We will see step by step. First step, step 1. Step first is resolve all the inclined forces. Resolve all forces. Resolve means you have to split the given force into its component. We will see in figure. If force F1, F2, F3, F4, F5, these 5 forces are acting. Then we have to resolve all the inclined forces. It is the first step. Resolution is very simple. If it is angle theta 1, F1 cos of theta 1, F1 sine of theta 1. It is theta 2, F2, then F2 cos of theta 2, F2 sine of theta 2. F4, if angle is theta 3, cos theta 3, F4 sine theta 3. So very important thing, the twist in F3 is, this F3 is seems like it is acting in third quadrant, but always remember the quadrant is depends on the direction of force. Here this F3 is directing in first quadrant, that's why it is acting in first quadrant. Quadrant is very important to decide the direction of component. F3 is in first quadrant, therefore horizontal component F3 cos theta 4 will be rightward and F3 sin theta 4 will be upward. F5, it is acting in fourth quadrant. F5, if angle is theta 5, cos theta 5, and here F5 sin theta 5. It is the first step. In first step we will resolve all the inclined forces. The force system may have horizontal force. For example, a force is acting F6 like this. We will not resolve because it is itself it is a horizontal. Now assume that these five forces are acting. These five forces, we have split each force into two components, and with components now the force system is of 10 forces. Initially the force system which is given, it is of 5 forces. After resolution it will become a force system of 10 forces. Second step is, after this resolution we will determine algebraic sum of horizontal forces, summation fx we will determine, and we will determine algebraic sum of vertical forces, summation fy. X we will represent all the forces along x axis or horizontal line, and y represent all the forces along vertical line or y axis. Now we have to add and subtract. Algebraic sum means we have to add and subtract. Very easy. When add and subtract is taking place in scalar quantity, it is very easy. 2 plus 2 4. But in vector quantity we have to see that direction also. That's why we require a sign convention. Sign convention is very important. We will consider rightward force as positive and leftward force as negative. Rightward positive, leftward negative. Similarly, upward force will be considered as positive and downward force will be considered as negative. Now in algebraic sum we will add all the component of the forces. The very important thing is that while taking the algebraic sum of x axis horizontal forces or vertical forces, we have to only consider the components. Means here we will consider f1 cos theta 1. We will see its direction. Its direction is rightward, therefore it will be considered as positive. Then f2 cos theta 2, it is leftward, it will consider as negative. Then f3 cos theta 4, it is rightward, therefore it is positive. Then f4 cos theta 3, it is acting towards leftward, that's why it is negative. And at the last, f5 cos theta 5, it is rightward. It is rightward, this component is rightward, that's why it is considered as positive. It is algebraic sum of horizontal forces. Similarly, algebraic sum of vertical forces, f1 sin theta 1, it is upward. Our sign convention, we have decided which one taken as positive, which one taken as negative. Upward will be positive, downward will be negative. Sin theta 1 is upward, it is positive. Second force, f2 sin theta 2, this one, it is also upward, positive. Third force, f3 sin theta 4, this force, it is upward, positive. f4 sin theta 3, it is downward, negative. And at the last, f5 sin theta 5, this force, it is downward, that way it is negative. It is second step, algebraic sum of all forces which is acting along x direction, along y direction. Now what is this? This fx and fy are two forces which are mutually perpendicular to each other. What is fx? This summation fx is representing the effect of all horizontal forces in the force system, and this summation fy is representing effect of all vertical forces in the force system. It means that initially the force system which has only 5 forces, after first step resolving all the forces, that force system converted into 10 forces, and with the help of summation fx and summation fy, again that force system becomes two force system. One is summation Fx and another is summation Fy. Both are mutually perpendicular to each other. Both are mutually perpendicular to each other means the angle in between them is 90 degree. And we know that whenever two forces are acting at a point, if you will use law of parallelogram of forces, resultant are equal to under root of F1 square twice F1 F2 cos of theta plus F2 square. So here theta between summation Fx and summation Fy is 90 degree, cos 90, 0. Therefore R is equal to under root of summation Fx square plus summation Fy square. It is the resultant of the force system. And if we will find the direction of resultant, tan inverse of mod summation Fy divided by summation Fx. It is very important formula. Now the given force system with the help of this formula is converted into a single force, and that single force is called as a resultant of the force system. I will repeat the step. The first step is resolve all inclined forces in the given force system, horizontal and vertical components. After resolution of forces, determine the algebraic sum of horizontal forces, determine the algebraic sum of vertical forces with the help of sign convention. Sign convention is very important. We have written here. Rightward force considered as positive, leftward as negative. Upward force will be positive and downward force is negative. After completing this summation Fx and summation Fy, we will use this formula R equal to under root of summation Fx square plus summation Fy square to determine the magnitude of the resultant. And direction of the resultant is given by alpha equal to tan inverse mod of summation Fy divided by summation Fx. But very important question is, in which quadrant this resultant is acting? The decision of quadrant of the resultant is depend on sign of summation Fx and summation Fy. If summation Fx is positive and summation Fy is positive, then we will see the quadrant. In which quadrant both are positive? In first quadrant summation Fx is positive and summation Fy is positive. If summation Fx and Fy both are positive, then it means that the resultant R is acting in first quadrant. If summation Fx is negative, summation Fy is positive, means Fx is acting towards leftward. Negative means leftward. Horizontal, negative means leftward. And vertical, upward. We will see the quadrant. In second quadrant, vertically is upward, horizontal is leftward. That's why the resultant will be acting second quadrant. If in some numericals summation Fx is positive, Fx positive means it is acting towards right, and summation Fy is negative means it is acting towards down. Then in fourth quadrant, horizontal is positive and vertical is negative. That's why resultant will be acting fourth quadrant. If both are negative, it means that horizontal summation Fx is towards leftward and vertical is acting towards downward. So resultant will be acting in third quadrant. These are some fundamentals. Now no need to remember sine rule, cosine rule and other principles to determine. Even though if two forces are acting concurrently, you may use this method instead of law of parallelogram of forces. Law of parallelogram force will also give you the resultant, and this method is also give you the resultant. It is a generalized method which is applicable to any number of force and any type of the force system. It is very important. Now we will summarize today's lecture. When two forces are acting, to determine the resultant we will use law of parallelogram of forces. But when number of forces are acting, we will use this general method to determine the resultant of the force system. First step is resolve all the inclined forces. All the inclined forces with the help of sine and cos. With horizontal there will be the force cos of angle, vertical force sine of angle. After the resolution, we will determine the algebraic sum of horizontal forces summation fx and algebraic sum of vertical forces summation fy. After this, for finding summation fx and summation fy, the very important thing is sign convention. We will consider rightward force as positive, leftward force as negative, upward force as positive, downward force as negative. After completing this summation fx and fy, it is very simple to determine the resultant of the force system with the help of this expression r equal to under root of summation fx square plus summation fy square. To have the inclination of resultant, alpha is equal to tan inverse mod of summation fy divided by summation fx. This mod we are using for to eliminating the negative sign, because from sign you can decide the quadrant. Then after decision of the quadrant, no need of the negative sign. Therefore, we will put this summation fy divided by summation fx into mod. So we will see the numericals in next lecture. I hope you are enjoying this lecture. If you have query, then you can mail me or you can use WhatsApp. Thank you.